My name is Alongkorn.
My name is Visuttharangsi.
We are the students of Visuttharangsi School. Our project is about the investigation of Papa's chain theorem using circle inversion. This project attempts to prove an ancient mathematical theorem in an intuitive way that can be appealing to the everyday mind. A mathematical proof will be used to understand the property of Papa's chain, known as the height of the center of the n squared circle above the line segment AB is equal to n times its diameter. This experiment involves mathematical proof. Circle inversion was the key. It allows the transformation of a point across the circle with the use of a right triangle. The second concept was arbilos. In a semicircle, another semicircle can be drawn. The chain of inscribed circles is sometimes called Papa's chain. For Papas of Alexandria, who studied and wrote about it in 4th century AD. The inscribed circles are tangent to one another and to the boundary of the arbilos, which state that the height of the center of the n inscribed circle above the line segment AB is equal to n times its diameter. A mathematical proof uses the ratio between the height of n inscribed circle and its prime and the diameter of n inscribed circle and its prime. Then this equation shows the height to the diameter with equal the height prime to the diameter and found height equal n times the diameter of n squared circle. This project used critical thinking and architectural geometry. In conclusion, this project allows the use of geometry and problem-solving skills.
The objective of this project is to research the Papa's chain theorem and circle inversion, to use the new knowledge and prove the theorem by myself. This project gives an opportunity to connect students, math, and technology skills. As you know that, the name of our topic is Investigating Papa's theorem using circle inversion. So, before going to Papa's theorem, I will explain you what is circle inversion. Inversion is the process of transforming point P. In order to find that P prime is the inverse of P, we need an inversion circle with inversion center O and inversion radius R. Q is a point of tangency joined with P. Make a perpendicular from Q that passes through OP. In order to find that P prime is the inverse of P, we have a formula if R squared equal to OP times OP prime, then P prime is the inverse of P. Look at two triangles, triangle OQP and triangle OP prime Q. This angle O is a common and these two angles are 90 degrees, so these two triangles are similar and sides are proportional. Therefore, OQ over OP equal to OP prime over OQ. So OQ is the radius, then we get R squared equal to OP times OP prime. The next concept is arbilos. An arbilos is a plane region bounded by three semicircles connected at the corners, and all are on the straight line that contains their diameters.
Papas of Alexandria was a mathematician who investigated the chain of the circle between two tangent circles. He proved that Hn is equal to 2nRn, where Hn is the height of n circle, Rn is the radius of n circle, and n is the number of the circle. So, this is known as Papa's chain theorem. As you can see, there are the circle in the arbilos. Suppose this one is the first, second, and third. According to the Papa's chain, from this circle, we get that H1 is equal to 2, 1, R1, or H1 is equal to 2, R1. And from this circle, we get that H2 is equal to 2 times 2 times R2, or H2 is equal to 4R2 and so on. If we inverse purpose chain, we get two parallel lines with equally sized circle that tangent to the parallel line and tangent to the circle next to them. Using construction, we get the triangle and using construction, we see the height of n circle Hn and it palms H palm n. And what is the radius Rn and its palm R palm n. We can create two more line segments. One is a view passing the center of n circle A C1 or Ln and its palm A S or L palm n. And one is a tangent A X and its palm A Q. So from this triangle, the triangle A C1 S and triangle A S Q are similar by using AAA similarity. So if the triangle are similar, the side will be proportional. So Rn divided by R palm n is equal to Ln divided by L palm n. And from this triangle, the triangle ATC1 and triangle AO palm 2 S are similar by using AAA similarity. So Hn divided by H palm n is equal to Ln divided by L palm n. So Rn divided by R palm n is also equal to Hn divided by H palm n. So H palm n is equal to 2nr palm n by using circle inversion. We get that Hn is equal to 2nrn, hence proof.
In conclusion, investigating purpose chain theorem using circle inversion was successful in its goal of proving purpose theorem in a mathematical way. In order to show that math can be easy from carrying out this experiment, I conclude that the height of the center of the n squared circle above the line segment A, B is equal to n times its diameter. I know this is true because the philosophy of the circle inversion doesn't change when using it to collaborate with purpose chain theorem. Thank you for your kind attention.